If we really want to understand what AI looks like in 2026, we can't just look at one piece of the puzzle. We have to build the entire thing, layer by layer. We're going to start at the very bottom with the silicon and work our way all the way up to how it's changing society. So, let's get building. So here's our roadmap. We're going to move through 5 key layers. First, we'll look at the hardware, the new engine driving everything. Then we'll get into the models themselves, the brains of the operation. After that, we'll see how we talk to them, which is changing fast, and how that leads to the rise of AI agents. And finally, we'll see how it all comes together in the real world. All right, first up, the foundation. You have to understand, every single leap forward we see in AI, every wow moment, it all starts with an almost unbelievable jump in raw computing power. And the jump happening in 2026 is a big one. And hey, you don't have to take my word for it. When NVIDIA pulled the curtain back on their next-gen AI platform called Rubin, the reaction was pretty immediate. Even someone like Elon Musk called it a rocket engine. And honestly, that perfectly captures the incredible scale and power we're talking about here. Now, this is a total game changer. The Rubin platform is set to slash the cost of AI inference. That's the cost of getting an answer from an AI by up to 10 times. So this isn't just about more power. It's about making that power way, way more affordable and accessible to everyone. That's huge. So how are they pulling this off? Well, it's not just one shiny new GPU. Rubin is a whole family of 6 different highly specialized chips. You've got your CPUs, your GPUs, and all the networking gear in between, all designed from the ground up to work together in perfect sync. This tight integration is the secret sauce that powers everything else up the stack. Okay, so you've got all this horsepower, right? But it's useless without the brains to actually drive it. And in 2026, those AI brains, the models themselves, are getting a serious upgrade. And that, of course, is sparking some pretty fierce competition. This table gives you a snapshot of the current AI wars. You're looking at the top contenders from Anthropic, OpenAI, and Google. And while they're all ridiculously powerful, you can see that each have their own special talents, whether it's in coding, reasoning, or something really important: safety. For instance, let's just zoom in on coding for a second. This benchmark, SWE Bench, isn't some abstract test. It uses real-world software bugs pulled directly from GitHub. And as you can see, Claude Opus 4.5 is in a league of its own. This means it's just flat out better at fixing the gnarly, complex problems that real developers wrestle with every day. And then there's the safety angle. This number here represents how often Claude gets tricked by what are called prompt injection attacks, basically people trying to hijack the AI. At just under 5%, it's way more robust than its competitors, making it a much safer bet for applications where you need the AI to operate on its own. Okay, so we have the hardware and we have these incredibly smart models. The next piece of the puzzle is, how do we actually talk to these things? That whole interaction is changing in a really fundamental way. We're moving away from just writing prompts and getting closer to actually programming them. You know, it used to be all about tweaking this weird setting called temperature to get more creative results. That's old news. Now, the real control knob is something called reasoning effort. When you set it to high, you're basically telling the model, hey, don't just spit out the first answer. Take a second, spend some of that expensive computing power and think this through. It's a much more direct way to get more accurate, logical answers. We're also getting much smarter about the internal language the AI uses to think. For things that involve space, like figuring out a path on a grid, using plain English is actually really inefficient. The new hotness is chain of symbol. It uses simple symbols instead of words, which is way more efficient and gets dramatically better results for those kinds of planning tasks. What this all means is that the days of painstakingly crafting the perfect prompt by hand, well, they're numbered. New tools like DS-Wi-Fi 3.0 work more like a compiler for a programming language. You just give it your goal, show it a couple of examples, and it automatically figures out and builds the absolute best, most efficient prompt for the job. And this is where it all comes together. When you combine that rocket engine hardware, those smarter models, and these new ways of programming them, you don't just get a slightly better chatbot. No, you get the next step in the evolution, an autonomous AI agent. You get a digital coworker. So how do these agents actually pull it off? Well, most of them use a really simple but powerful loop called react. It's a 3-step dance. First, the agent reasons. It thinks about the goal and what its next step should be. Then it acts. It uses a tool, runs some code. And finally, it observes the outcome.
It's just think, do, see, and then it repeats that loop until the job is done.
This simple loop is what unlocks the capabilities that make an agent so different from a simple assistant. We're talking about an AI that can pursue long-term goals on its own, like planning an entire multi-city business trip from start to finish. It can learn from your feedback and actually get better over time. And this is the really wild part. It can team up and communicate with other AI agents to handle incredibly complex projects. So we've built the whole stack, from the silicon all the way up to these autonomous agents. For our final layer, let's look at what this all means in the real world. How are businesses actually putting this stuff to work right now? Well, according to a recent report from Deloitte, the big win for most companies, about 2/3 of them, is in productivity and efficiency. They're doing the same things, just faster and cheaper. Only about 1/3 are really using this power to totally reimagine their business or create brand new things. So while AI is definitely making an impact, it seems like most are just scratching the surface of what's possible. We're seeing this explosion in the use of agentic AI. It's happening, and it's happening fast, which of course raises the one critical question that every leader is asking themselves. As these autonomous systems get more and more powerful, do we have the guardrails in place to handle them? And the answer, for now at least, is a little scary. That same Deloitte report found that only 1 in 5 companies feels like they have mature governance and safety systems in place for these AI agents. Think about that. That's a huge disconnect, right? The technology's capability is racing forward, but our ability to safely manage it is lagging way behind. Which brings us to our final and maybe most important question. The whole stack is here. The hardware is ready, the models are smart enough, and the agents are capable. AI is becoming our coworker, our collaborator, maybe even our companion. The technology is ready. The real question for 2026 and beyond is, are we? Are we ready for the deep psychological shift that happens when intelligence is no longer an exclusively human trait?